The future of humanity lies among the stars. Space colonies are no longer science fiction. They are becoming real. From the moon to Mars, Europa to Titan, humans are learning to survive, explore, and thrive in environments far beyond Earth. Join us as we uncover 100 fascinating facts about life, technology, and survival in the colonies of tomorrow. Chapter 1. In the future, the first space colonies form on the moon, built from lunar dust turned into bricks with solar-powered printers. Life begins inside sealed habitats, where water is recycled so well that almost nothing is wasted. People learn to walk under weaker gravity, discovering how even small steps can feel strangely freeing. Chapter 2. Mars becomes the second home for humans, shaped by underground shelters protecting settlers from radiation. Engineers use Mars's frozen soil to create oxygen and fuel, turning the planet into a self-growing outpost. Every sunrise has a red tint, reminding colonists how far they've traveled, and how survival is now a daily scientific routine. Chapter 3. Floating cities appear above Venus's thick clouds, where the air is cooler and safer. These stations use giant balloon-like structures filled with breathable air to stay afloat. Scientists study Venus's weather to design lightning shields, making the colony both a research hub and a rare place with golden, endless sunsets. Chapter 4. Asteroid colonies emerge next, small habitats anchored to giant rocks. Miners extract metals that Earth can no longer easily provide. Robots do most of the cutting, while humans oversee operations from protected domes. These colonies grow into hubs of manufacturing, turning raw space materials into tools for further expansion. Chapter 5. Orbital greenhouses stretch like long glass tunnels around Earth. They produce fresh vegetables using sunlight reflected from mirrors. With no storms or insects, crops grow faster and cleaner. These farms feed nearby colonies, proving that food independence in space is possible and opening the door to full off-world living. Chapter 6. New propulsion systems cut travel time between colonies. Plasma engines push ships faster while using less fuel. Travelers describe the silence of deep space as peaceful, with stars appearing sharper than anywhere near Earth. Faster travel links distant settlements, forming the first interplanetary network of routes and trade. Chapter 7. Medical labs in microgravity discover treatments impossible on Earth. Without gravity, cells grow differently, revealing behaviors hidden for centuries. Doctors produce advanced vaccines and new regeneration therapies. Space colonies become health centers, drawing patients from Earth seeking specialized care only available in orbit's unique conditions. Chapter 8. Education changes as children grow up in reduced gravity. They learn balance differently, developing stronger control of their bodies. Lessons combine science with daily tasks like maintaining oxygen systems. Space schools teach survival skills along with math and history, shaping a generation that sees space as home, not frontier. Chapter 9. Saturn's moon Titan hosts methane-powered colonies. Thick atmosphere protects settlers from radiation, and its lakes become energy sources. Engineers build floating platforms that resist extreme cold, turning Titan into a research station for studying early Earth chemistry. Colonists describe the orange haze as eerie but strangely calming. Chapter 10. In deep space, rotating cylinder habitats simulate Earth-like gravity. Massive mirrors bring sunlight inside, creating parks, lakes, and neighborhoods that feel familiar. These habitats travel slowly between planets, acting like moving towns. People aboard live normal lives, working, farming, raising families, proving humanity can thrive even while endlessly drifting. Chapter 11. Mining colonies in Jupiter's orbit use giant magnetic shields to survive intense radiation. Workers operate from heavily protected modules while drones gather gases for fuel production. These outposts become the power stations of the solar system. Every day feels like balancing science and danger, but the rewards push humanity deeper into space. Chapter 12. Lunar night farms develop under heated domes, using powerful LEDs to grow food during the moon's long darkness. Scientists refine plant genetics, so crops need less water and adapt to low gravity. These farms allow long-term settlement and make the moon more than a research base. It becomes a sustainable living world. Chapter 13. Martian cities expand with transparent tunnels connecting districts. These tunnels protect from dust storms while letting sunlight through. Residents travel by electric pods, creating silent, efficient movement. Over time, these cities blend nature and engineering, filled with red rock gardens that remind settlers they turned a hostile planet into a functioning home. Chapter 14. Interstellar probes act as scouts for future colonies, using tiny light sails pushed by lasers. These probes send back maps of new systems long before humans arrive. Their discoveries help future missions choose safe landing zones and resource-rich planets, making exploration strategic rather than risky guesswork. Chapter 15. Robotic construction teams build habitats before humans even land. They assemble shells, test air seals, and prepare life support systems. When humans arrive, the bases feel almost move-in ready. This automation makes expansion much faster, allowing multiple colonies to develop at once without waiting for large crews. Chapter 16. Space elevators finally rise from Earth's equator, cutting launch costs dramatically. These structures allow daily cargo trips without rockets. The elevator cars glide smoothly upward, carrying people, materials, and entire modules for new colonies. With cheaper access to orbit, humanity moves from occasional missions to a constant flow of travelers. Chapter 17. Artificial forests grow inside orbital rings around Mars, creating controlled ecosystems. These forests purify air, recycle water, and support diverse species. Scientists study how animals adapt to lower gravity, discovering new behaviors and improved mobility. These ecosystems mark the first attempt to rebuild Earth's biodiversity beyond its own skis. Chapter 18. Helium-3 harvesters on the moon produce clean fusion fuel for space colonies. Massive collectors sweep across lunar plains, gathering particles trapped in the soil. This fuel becomes essential for powering distant settlements, giving the moon a new identity, not just a scientific outpost, but a global energy partner. Chapter 19. Deep space communication arrays use quantum links to reduce delays. These systems transmit information securely across massive distances, keeping colonies connected even when separated by millions of kilometers. The technology prevents isolation, allowing real-time medical support, education, and governance between remote outposts and Earth. Chapter 20. Transport hubs appear in orbit around major planets, acting like interplanetary airports. Ships dock, refuel, and transfer cargo before continuing their journeys. These hubs become busy crosspoints where travelers from different colonies meet. Over time, they grow into cultural centers filled with stories, trade, and the shared spirit of exploration. Chapter 21. Ice mining colonies on Europa drill through its frozen shell to study the ocean below. Submarine drones explore warm vents where life might exist. The colony relies on heat extracted from the moon's crust, creating a stable energy source. Every discovery from Europa reshapes our understanding of biology and where life can thrive. Chapter 22. Mercury hosts solar collection towers that gather extreme sunlight and beam energy across the solar system. Colonists live underground to escape heat, using cooling systems powered by the very sun that threatens them. Mercury becomes a strategic energy supplier, proving even the harshest worlds can support human ingenuity. Chapter 23. Space manufacturing plants create materials impossible to form on Earth. Microgravity allows perfect crystals, ultra-clean alloys, and stronger fibers. These materials support everything from medicine to shipbuilding. Over time, orbital factories become essential for advanced technology, shifting industry from Earth's surface to its skis. Chapter 24. Terraforming experiments begin on Mars with engineered microbes designed to slowly thicken the atmosphere. Scientists release them in controlled zones, monitoring how they convert carbon dioxide into useful gases. Progress is slow, but each change marks humanity's first attempt to reshape a planet on a biological level. Chapter 25. Communications satellites orbit every colony, forming a universal time system for space. This shared clock keeps missions synchronized, prevents navigation errors, and simplifies trade routes. A stable time standard becomes the backbone of an expanding civilization that can no longer rely only on Earth's familiar 24-hour cycle. Chapter 26. Hydroponic towers rise inside asteroid bases, producing continuous fresh food. These towers recycle air and water, creating small pockets of green life inside rocky shells. For miners spending months in deep space, these gardens provide both nutrition and emotional comfort, reminding them of Earth's natural rhythm. Chapter 27. Long-distance freight ships grow massive, carrying entire modules for new colonies. They travel slowly but efficiently, powered by solar sails and fusion engines. Crews aboard treat these ships like drifting towns, working in shifts to maintain systems during multi-month journeys. These vessels become the lifeline of expansion. Chapter 28. Tourism emerges as people visit the Moon, Mars, and orbital hotels. Guests experience low-gravity sports, panoramic views, and silent nights far from Earth's noise. Tourism helps colonies fund research while spreading appreciation for space. Many visitors return changed, seeing humanity's future more clearly after witnessing it firsthand. Chapter 29. new legal systems form to manage property, safety, and trade between colonies. These laws evolve from maritime rules and scientific agreements, but adapted for vacuum environments and long communication delays. The framework ensures cooperation, preventing conflicts that could threaten fragile settlements scattered across space. Chapter 30. Cryohospitals store patients in deep sleep for long journeys or major medical treatments. Advanced monitoring keeps them stable for months. These facilities make distant travel more accessible and reduce strain on limited resources. Cryotreatment becomes a trusted option that blends science and survival in the cold depths between worlds. Chapter 31. Venus cloud cities expand with modular platforms that can float and link together. Residents travel between sections using pressurized walkways or air capsules. Engineers study storms constantly, adjusting altitude to avoid turbulence. Life here blends extreme science and daily routine, proving humans can adapt to even the most hostile skis. Chapter 32. Orbital laboratories grow replacement organs using microgravity. Cells form stronger, more precise structures than on Earth. These organs are shipped to hospitals worldwide, saving lives. Colonies become crucial medical centers, demonstrating that microgravity isn't just survival, it's a laboratory for groundbreaking health discoveries. Chapter 33. Asteroid belt colonies form trade networks, exchanging rare metals, water, and advanced tech. Small ships ferry goods between rocks while larger carriers navigate through gravitational currents. This growing economy turns once isolated rocks into bustling hubs, showing that commerce in space can evolve faster than settlement. Chapter 34. Lunar observatories track Earth's weather, solar storms, and distant galaxies. Being above the atmosphere gives unprecedented clarity. Scientists discover new patterns and refine space weather predictions. Colonists rely on this information to protect energy grids and habitats, blending research with survival in an increasingly interconnected system. Chapter 35. Mars hosts robotic farming colonies with automated harvesters and AI caretakers. Robots manage planting, watering, and nutrient cycles, while humans focus on expansion and exploration. These farms ensure food security for growing populations, turning previously barren plains into productive, life-sustaining landscapes. Chapter 36. Titan settlements use floating platforms above liquid methane lakes. Energy is harvested from chemical reactions, while atmospheric balloons provide stability. Residents wear heated suits outside the modules, and inside, habitats mimic Earth's warmth. Titan becomes a playground for science and exploration, where life persists in orange-tinted alien skis. Chapter 37. Space elevators on Mars cut costs and risks for orbital transfers. Cargo moves in pressurized pods, transporting supplies, fuel, and construction materials. These elevators enable faster colony growth, linking surface settlements with orbital labs. Over time, they create an efficient network critical for long-term survival and industrial expansion. Chapter 38. Artificial gravity domes rotate to simulate Earth's gravity for sports, recreation, and exercise. Residents learn to balance differently than in low-gravity zones, gaining unique agility. These spaces keep muscles strong and spirits high, showing that design can overcome one of space's biggest challenges, living comfortably away from Earth's pull. Chapter 39. Deep space telescope platforms monitor distant stars and exoplanets. They operate far from sunlight and interference, capturing details impossible from Earth. Colonies rely on their discoveries to plan future settlements. Each observation sparks new questions, proving that exploration isn't just physical, it's a mental journey expanding human knowledge. Chapter 40. Orbiting power stations beam energy to remote colonies. Giant solar arrays collect sunlight continuously and transmit it via microwaves. This energy fuels habitats, greenhouses, and engines. Space energy systems make settlements independent, showing that even without fossil fuels, human expansion can be sustainable across vast distances. Chapter 41. Europa's ice labs study microbial life in subsurface oceans. Drills create safe observation chambers while submarines explore deep waters. Scientists discover chemical reactions hinting at early life forms. These findings suggest that life can exist beyond Earth, making Europa both a home and a window into the origins of biology across the cosmos. Chapter 42. Orbital refueling stations reduce dependency on Earth launches. Ships stop to collect fuel, oxygen, and water before continuing to distant colonies. This system allows for faster, longer, and safer travel. Colonists call these stations lifelines in the void, essential infrastructure for an expanding human presence in the solar system. Chapter 43. Microgravity schools teach children to think and move differently. Lessons include spatial reasoning, low-gravity sports, and habitat maintenance. Students grow physically stronger in unique ways while learning problem-solving skills adapted to space life. Education becomes practical and scientific, preparing the next generation for off-world independence. Chapter 44. Mars, underground cities expand with lava tube settlements. Natural rock shields protect residents from radiation and storms. Inside, modular living spaces, greenhouses, and labs form self-contained communities. These tunnels become hubs for research, industry, and culture, showing how humans can turn natural structures into functional habitats. Chapter 45. Asteroid processing plants convert rock into building materials and fuel. Automated machinery extracts metals, which are then refined for construction or energy. This method reduces the need to launch materials from Earth, making deep space settlements more self-sufficient and sustainable, and proving resourcefulness is humanity's strongest tool. Chapter 46. Lunar water extraction becomes critical. Colonists drill beneath the surface to reach ice deposits, then purify water for drinking, agriculture, and oxygen production. The success of these systems allows longer missions and larger settlements, transforming the moon into a practical stepping stone for interplanetary expansion. Chapter 47. Mars weather stations provide real-time data for storms, temperature shifts, and dust cycles. Sensors predict dust storms that could halt travel or harm solar panels. Colonists rely on this information to plan outdoor work and energy usage, blending science with daily survival on a volatile red planet. Chapter 48. Saturn's rings host research stations that study ice particles and magnetic fields. Colonists deploy drones to sample material while monitoring radiation. Findings improve understanding of planetary formation and resource potential. These stations show that even the most beautiful regions of space hold critical scientific value. Chapter 49. Floating hydroponic farms in orbit grow fresh food for multiple colonies. Plants rotate through sunlight mirrors and nutrient systems, producing high yields in small space. Colonists report these gardens improve mood and health. Food production in space evolves from necessity to science-driven sustainability. Chapter 50. Cryogenic archives preserve human knowledge for centuries. Libraries in space protect data from disasters on Earth. Digital and physical storage allows colonies to retain culture, science, and history. These archives ensure that even as humanity spreads across planets, its collective memory remains intact. Chapter 51. Titan's colonies use methane fuel harvested from lakes and rivers. Floating platforms convert chemicals into energy, while residents live inside insulated habitats. Engineers continuously monitor pressure and temperature to avoid accidents. Titan becomes a unique testbed for extreme environment survival, teaching humanity how to thrive where Earth-like conditions don't exist. Chapter 52. Deep space communication relies on quantum entanglement, allowing near-instant data transfer across millions of kilometers. Colonists send instructions, research, and medical data instantly, reducing isolation. These links connect every settlement to Earth, creating a shared knowledge network essential for survival and collaboration in far-flung regions of the solar system. Chapter 53. Orbital construction bots assemble massive space stations with precision impossible for humans. Modules, mirrors, and solar arrays fit together seamlessly. Colonists oversee operations from nearby pods, ensuring safety. Automation accelerates expansion, enabling faster growth of habitats, labs, and energy facilities that form the backbone of off-world civilization. Chapter 54. Mars' underground ice storage preserves water for dry seasons. Engineers carefully manage extraction and recycling to maintain balance. These reservoirs allow agriculture, drinking water, and oxygen production to continue uninterrupted. Resource management becomes an essential skill for every colonist, blending survival with scientific planning. Chapter 55. Venus. High-altitude colonies use floating solar arrays to gather sunlight above thick clouds. Platforms drift with wind currents, maintaining stability. Residents adapt to 0.9 gravity and engineered living pods. Venus becomes a laboratory for studying atmospheric science and sustainable energy collection, proving colonization can happen even in extreme conditions. Chapter 56. Asteroid mining ships deploy fleets of small drones that carve, scan, and transport minerals. Humans supervise operations remotely, avoiding direct exposure. These colonies generate rare metals for electronics, construction, and propulsion. Space mining turns once barren rocks into productive industrial hubs that fuel interplanetary expansion. Chapter 57. Lunar lava tubes host long-term habitats, shielded from radiation. Colonists install modular living units and greenhouses inside natural tunnels. These tunnels offer natural insulation and protection, demonstrating that using planetary features wisely can reduce energy needs and increase settlement sustainability. Chapter 58. Orbital telescopes discover habitable exoplanets, guiding future human missions. High-resolution imaging captures atmospheres, oceans, and climates. Scientists analyze data to determine resources, dangers, and potential landing sites. These discoveries inspire new generations to dream beyond the solar system, connecting science with human curiosity. Chapter 59. Space hospitals perform surgeries using robotic arms and remote specialists. Microgravity aids precision, allowing delicate procedures impossible on Earth. Patients recover faster thanks to controlled environments and advanced monitoring. Colonies become health hubs, proving that space medicine can surpass Earth-based limitations. Chapter 60. Martian wind turbines capture energy from constant dust storms. The turbines convert strong winds into electricity for colonies. Combining renewable energy with solar arrays ensures continuous power. Residents learn to adapt infrastructure to local conditions, blending engineering and survival into everyday life. Chapter 61. Space gardens inside orbital rings recycle air, water, and nutrients continuously. Plants grow faster in low gravity, providing fresh food and oxygen. Colonists enjoy green spaces for mental health, combining science and well-being. These gardens show that life in space can be sustainable, productive, and emotionally nourishing at the same time. Chapter 62. Europa's submarines explore hidden oceans, mapping the seafloor and searching for life. Colonists remotely operate the vessels from ice shelters above. Each discovery, microbial colonies or unusual chemical reactions, teaches how life might survive in extreme environments, expanding humanity's understanding of biology beyond Earth's boundaries. Chapter 63. Deep space research ships test advanced propulsion, including plasma and ion drives. These engines shorten travel time between colonies while conserving fuel. Crews conduct experiments while drifting in the void, proving that innovation is essential for connecting distant worlds and sustaining a growing interplanetary civilization. Chapter 64. Orbital asteroid hubs serve as supply points for traveling ships. Drones deliver cargo, while residents manage logistics from shielded modules. These stations stabilize trade routes and make deep space travel predictable and safe. Over time, they form the backbone of a structured interplanetary economy. Chapter 65. Mars greenhouse towers use LED lighting and hydroponics to grow crops year-round. Plants adapt to low gravity, providing nutrition and oxygen. Colonists rely on these towers for survival and experiment with plant genetics, showing how science transforms barren landscapes into productive, life-sustaining environments. Chapter 66. Floating laboratories above Venus drift in the atmosphere, studying chemical reactions and weather patterns. Residents maintain life support systems while collecting valuable atmospheric data. These colonies combine adventure and research, proving humans can live in extreme conditions with careful planning and engineering. Chapter 67. Orbital manufacturing plants produce ultra-precise materials impossible to create on Earth. Microgravity allows perfect crystals, advanced alloys, and high-purity compounds. These products support spacecraft, electronics, and medicine. Space production becomes essential, turning orbiting stations into industrial powerhouses beyond Earth's limitations. Chapter 68. Cryogenic transport allows patients and scientists to travel for months without aging. Advanced monitoring ensures safety. Colonists use cryo for medical emergencies, research missions, or relocation. These systems make distant travel feasible and safe, blending human biology with futuristic engineering. Chapter 69. Lunar solar farms capture continuous sunlight, converting it into electricity for colonies and orbital stations. Energy is stored in massive batteries or transmitted via microwaves. These installations provide independence from Earth and create reliable power systems critical for life and industry in space. Chapter 70. Asteroid research stations monitor mineral-rich rocks, mapping resources for mining and settlement. Drones scan surfaces and relay data to orbital labs. Findings guide colonists in choosing extraction sites, reducing risk. Space exploration becomes more calculated, combining observation, technology, and human ingenuity for efficient expansion. Chapter 71. Mars, underground laboratories study radiation effects on humans and plants. Thick rock shields protect experiments while scientists test new shielding materials. Findings improve habitat design across colonies. Knowledge gained ensures humans can survive in harsh conditions and pushes engineering and biology to new levels of innovation in extreme environments. Chapter 72. Orbital rings around gas giants act as research and observation platforms. High above turbulent atmospheres, sensors track storms, magnetospheres, and moons. Colonists analyze data for energy, navigation, and planetary science. These stations combine safety, efficiency, and scientific opportunity in places unreachable from planetary surfaces. Chapter 73. Space elevators on Mercury reduce rocket dependency. Pods transport cargo and personnel between orbit and surface, cutting costs dramatically. Engineers develop heat-resistant materials to survive extreme temperatures. The elevator system becomes essential infrastructure, proving that human ingenuity can overcome even the most hostile planetary conditions. Chapter 74. Floating ice colonies on Europa harvest frozen water for fuel and drinking. Automated systems melt, purify, and distribute water safely. Colonists live in insulated habitats, using the moon's resources to sustain life. Europa becomes a laboratory for off-world water management and energy efficiency. Chapter 75. Orbital medical stations conduct regenerative medicine research in microgravity. Cells grow differently than on Earth, allowing organs and tissues to develop faster and stronger. Colonies use these advances to treat patients locally and ship results to Earth. Space medicine becomes a cutting-edge field that benefits all humanity. Chapter 76. Lunar habitats integrate radiation shielding into their walls using regolith. Colonists build layers of lunar soil to block harmful particles. This approach allows safer long-term living, reduces material transport from Earth, and demonstrates how humans can adapt natural planetary features for survival. Chapter 77. Mars' energy grid combines solar arrays and wind turbines to maintain consistent power. Dust storms test the system, forcing engineers to develop robust storage solutions. Colonists learn to anticipate energy fluctuations, blending science, engineering, and daily life for sustainable settlement. Chapter 78. Orbital observation platforms detect meteoroid paths, warning colonies of potential impacts. Automated deflection systems redirect small debris while humans monitor larger threats. This proactive safety network keeps settlements protected and demonstrates how space colonization depends on both technology and foresight. Chapter 79. Titan's chemical labs convert atmospheric methane into fuel and plastics. Residents study reactions in extreme cold, creating energy and materials simultaneously. These experiments reveal the potential of using local resources to maintain independent, self-sustaining colonies on distant worlds. Chapter 80. Deep space freighters transport modules and supplies between colonies. Ships travel in convoy for safety, using advanced propulsion and navigation systems. Life aboard combines work, recreation, and maintenance of systems. These vessels connect settlements, making interplanetary trade, construction, and travel efficient and practical. Chapter 81. Mars' communication network uses satellites in orbit to maintain real-time links with Earth and other colonies. Data travels via quantum entanglement for instant updates. Colonists coordinate transport, energy, and research seamlessly. These networks transform isolated settlements into connected civilizations, showing that communication is as vital as food, water, and shelter in space. Chapter 82. Orbital agriculture stations grow protein-rich algae for food and oxygen. These farms recycle waste while producing essential nutrients. Colonists monitor growth using AI, optimizing conditions for maximum yield. Algae-based diets provide sustainable nutrition and highlight how science adapts Earth's resources for survival beyond the planet. Chapter 83. Lunar industrial zones process metals extracted from the moon's surface. Automated smelters refine ore into usable materials for construction, energy, and spacecraft. Colonists oversee quality and safety, demonstrating how local resources reduce reliance on Earth and enable faster expansion throughout the solar system. Chapter 84. Asteroid observation stations track orbital paths to prevent collisions with colonies or Earth. Sensors measure speed, mass, and trajectory. Small deflection missions redirect dangerous objects. Safety systems become essential for survival, proving that even minor celestial objects can influence long-term settlement plans. Chapter 85. Mars' volcanic regions host geothermal power stations. Heat from underground magma converts water into steam to generate electricity. Colonists build habitats nearby, using natural energy to reduce dependence on solar power. These systems blend engineering, geology, and sustainability for resilient colonies in harsh environments. Chapter 86. Venus cloud cities rotate slowly to maintain stability in turbulent winds. Residents monitor air pressure and temperature constantly. Research focuses on energy collection and chemical analysis. These floating settlements demonstrate that life can exist in extreme atmospheres with careful design and scientific planning. Chapter 87. Orbital manufacturing hubs assemble spacecraft, modules, and satellites. Robots construct precision parts in microgravity impossible on Earth. Colonists supervise operations and maintain infrastructure. These hubs become essential for building larger colonies, fueling interplanetary travel, and supporting exploration of new worlds. Chapter 88. Deep space research vessels test AI-controlled navigation and life support systems. Crews monitor autonomous operations to optimize efficiency. These ships shorten travel time between colonies and reduce human workload, proving that advanced technology is crucial for sustainable expansion into distant regions. Chapter 89. Europa's subice habitats support scientific teams studying potential life in oceans. Heated modules provide safety and comfort, while drones explore beneath. Data collected on microbial life and chemical reactions expands understanding of biology beyond Earth, making these colonies vital research centers for astrobiology. Chapter 90. Titan's floating energy platforms supply power to local colonies and orbital stations. Methane-based fuel supports engines, heating, and industrial processes. Residents monitor production and distribution carefully. These systems prove that even cold, distant worlds can sustain human activity if energy is efficiently managed and harvested locally. Chapter 91. Orbital recycling centers process waste from multiple colonies. Materials are sorted, purified, and reused in construction, energy systems, and life support. Efficient recycling reduces supply needs from Earth, showing that closed-loop systems are essential for long-term survival and sustainable growth in space settlements. Chapter 92. Mars robotic exploration teams map uncharted regions for future settlement. Drones and rovers survey terrain, detect hazards, and locate resources. Colonists use this data to plan expansion safely. Robotics ensures exploration is precise, fast, and safe, turning unknown landscapes into predictable environments ready for human habitation. Chapter 93. Lunar observatories detect near-Earth asteroids and monitor space weather. Sensors track solar flares, radiation, and debris. Colonists adjust energy systems and shelters based on real-time information. Observation becomes a survival tool, proving that staying informed is as important as infrastructure in space. Chapter 94. Orbital educational centers teach science, engineering, and survival skills. Students interact with virtual simulations, low-gravity labs, and habitat maintenance tasks. Education is hands-on and directly linked to colony needs. These centers prepare new generations to thrive in diverse environments across the solar system. Chapter 95. Titan's chemical laboratories produce life support compounds from local resources. Methane and nitrogen are transformed into oxygen, fuel, and building materials. Residents manage processes carefully, creating a closed-loop economy. Colonies learn that resource efficiency is critical in distant worlds with limited external supply. Chapter 96. Space-based weather satellites provide data for all colonies. Sensors track storms on Mars, solar activity, and orbital debris. Colonists plan outdoor work, energy use, and travel based on forecasts. These systems blend science and survival, demonstrating the importance of prediction in a multi-planet civilization. Chapter 97. Deep space propulsion testing centers trial nuclear, plasma, and ion engines. These experiments improve travel speed, efficiency, and cargo capacity. Colonies benefit from faster connections and safer logistics. Advanced propulsion marks the difference between isolated outposts and an interconnected interplanetary network. Chapter 98. Lunar biodomes support small ecosystems, including plants, insects, and fish. Life cycles are monitored to optimize air, water, and food production. Colonists learn ecosystem management, creating self-sufficient habitats. These domes become blueprints for off-world agriculture and sustainable living. Chapter 99. Orbital entertainment hubs provide cultural activities, exercise, and social spaces for colonists. Low gravity allows unique sports and experiences impossible on Earth. Recreation becomes essential for mental health and community building, proving that life in space requires more than survival. It requires balance and human connection. Chapter 100. Interplanetary trade networks connect every colony with resources, knowledge, and personnel. Ships carry energy, food, technology, and culture between worlds. Colonies thrive as interconnected hubs, showing that collaboration, planning, and innovation make humanity not just surviving but truly living among the stars. The journey to space is just beginning. Every discovery, invention, and settlement brings humanity closer to becoming a true interplanetary species. The future is vast, exciting, and full of possibilities. These 100 facts remind us that space isn't just a place, it's our next home, and the adventure has only just begun.